Now let's discuss how science works. Right now, with COVID-19, there's a lot of discussion about science, and it's definitely front and center, as well as the relationship between science, scientists, and the general public, which I would argue are exactly the same thing. But let's talk about the all the different disciplines that make up science. And you can see here this little example. There's a lot of different things that are science. Of course, there's math, there's the study of astronomy, there's the study of geology, there's the study of chemistry and technology. These are all different sciences. And some people divide those up into life sciences and applied sciences. Indeed, there's a lot of ways to look at all of the different scientific disciplines and to divvy them up. This chart for me is kind of confusing, but I want you to notice on the left side that we're trying to organize science on a scale level. So looking at things on a small scale versus on a larger scale. And you'll see that kind of within this between atom and earth size scale, we have the life sciences. And there you'll find functional biology and cellular biology. You also find the social sciences and psychology. And these are all things that are rooted in living things. Remember, we defined what a living thing is. Well, the study of living things and kind of the consequences of living things all is embedded in that scale between the atom and the solar system. You find that scale. And so we're really going to be looking at the life sciences this semester. The physical sciences and the formal sciences, you can see, are very important, especially at the tiny scale, below the scale of the atom. And also on these larger scales, as we start looking at the solar system and the Milky Way and just the entire universe, you have to really root yourself in math, physics, and your understanding of physics. And so these are all sciences, but what's something that's helpful for me to keep in mind is that you don't have to be an expert at chemistry and physics to learn a whole lot about biology. And you don't have to be a mathematician to gather some insight into the world using physics. A lot of this stuff is a little more intuitive than you'd think. And that's what we're going to try to do this semester. We're going to try to give you the tools. I'm going to try to give you the tools to learn about biology and learn about science without necessarily being a chemistry whiz or a physics whiz or a math whiz, because I certainly am not any one of those things. So this is a great example of all the different sciences that exist. They certainly do play an important part in our daily lives. Technology is an example of applied science, but there's a lot of different methods that we use, different methodologies we use to understand the world in a scientific way. And that's what we're going to talk about next. But before we go into that conversation, I'd like to first kind of prepare you for an understanding of how we look at the world and to kind of take note of a potential bias in everything we discuss. I think this is an important conversation because as we look at our understanding of the world, it's important to look at the filters and the channels that information had to go through. And then we can think about how we might change that in the future. And so what do I mean by that? Well, on the left is the distribution of the top universities on Earth. So just think about this from a biological perspective. If we're trying to understand life on Earth, we're trying to understand living things, this is where all of the science goes through, right? It goes through the universities. And you can see that they're heavily biased towards temperate regions. They're heavily biased towards Europe. They're heavily biased towards the East Coast and the coasts of the United States. And there's some hot spots there, and also on the coastal areas of China and in Australia. These are all temperate regions. On the right, you can see an example of all the diversity of planet Earth. And you can see that the most diverse places, which include the Amazon basin, which includes equatorial regions of Africa, these are the places with the most speciose habitats, the most species of amphibians, the most species of mammals, the most species of birds. These are the places that have the most life. You can see here that these areas that are hotspots for animal diversity, indeed, if you wanted to understand life on Earth, this is probably where you would want to be. There are also these places that are devoid of institutions like universities and higher education. Now that we've illuminated this potential bias, let's continue talking about science. This was just something I wanted to mention early on to kind of give you some tools when framing how we view a lot of different things. And I might touch upon this pattern in future lectures and different times, and I'll usually refer to it as a temperate zone bias, which is likely why we know so little about so much of biological diversity. So let's talk about the kinds of reasoning and the kinds of thinking that go into the framework of science. So the first thing we want to talk about is inductive reasoning. Inductive reasoning is a process of observation. It's a way of looking at the way things are and thinking about how there's a pattern and observing those patterns and documenting those patterns. It doesn't necessarily mean you're doing an experiment, but this is an important step and stage and process in science. In this example, you have Jane Goodall, a famous primatologist. She's observing chimpanzees, and she's not doing an experiment necessarily. She's not performing replicates of this moment or anything like that. She's simply taking notes and generating ideas and observing what's happening before her. And this is actually a very important stage in science. And even in experimental science, you're often going back into this stage and going back and forth. So let's look at another example of inductive reasoning. And this is actually a published paper. This is a descriptive paper. It's a journal article talking about the luminescence of a millipede. So someone observed that these millipedes glow in the dark. They're glowing at night, and they took notes and they observed this. And they even, on the top right, you can see they even measured the wavelengths that were reflecting off of this millipede. They didn't necessarily do an experiment, but really this is an example of inductive reasoning, the observation of what's happening in nature, and just the documentation of that. Now is a great opportunity for you to think about this scenario and to make some guesses as to why this millipede glows in the dark. And that's when you'll transition from inductive reasoning to deductive reasoning.